Alright, this video is in response to some requests that I've had to do some problems. So the types of problems that are going to be done in this video, hopefully one with a working pen. Alright, we'll go moles to mass and back. Okay, we'll go moles to and from what we call formula units. Okay, a formula unit is either, an atom or a molecule. Okay, you can classify them collectively as formula units. Okay, and then also from formula units to mass and back and forth. So there's 6 different problems there. And then I'll also do a couple molar mass calculations, as well as molar mass of both. We'll go a covalent compound and an ionic compound. Okay, so we have a grand total of 8 different things we're going to have in this video. So let's go ahead and get started. Okay, so let's go ahead and say we had 2.64 moles of oxygen gas, or say oxygen atoms, okay, or let's go oxygen gas, why not? Okay, and then we need to convert this into mass. Okay, actually, let's just make this plain simple O, oxygen atoms. So 2.64 moles of O, and I want to find the mass, and of course this mass is going to be in grams. So I start with what I'm given, 2.64 moles of O over 1, and then I know, according to the periodic table, that there are 16.00 grams of O for every mole of O. So 1 mole of O is 16.00 grams O. My moles cancel out. I'm left with grams of O, which is what I'm looking for. Just real quick. Okay, doing the math. Okay, we'll go 16.00 times 2.64. My answer is, in blue, of course, 42.24 grams. However, I need to have 3 sig figs, so I lose that number. So it should be 42.2 grams of O. Now, let's say I wanted to go backwards and say I had a mass and I wanted to get back to moles. So let's say I had 342.6 grams of fluorine, and I want to convert that into moles. Okay, I'm doing the same process, but I'm going to go backwards. Okay, so I want to get to moles of fluorine. So I'll go 342.6 grams of fluorine over 1. And I know that I need to get grams canceled out, so I'll put grams of fluorine on bottom, moles of fluorine on top. Well, 1 mole of fluorine, if looking at the periodic table, is 19.00 grams. So, doing my math, 342.6 divided by 342.6 divided by 19.00 is going to be 18.03 moles of fluorine. Okay, and of course the reason why I'm going to go that, I'll cancel out my grams. I get moles of fluorine there. Okay, I have 4 sig figs because I have 4 sig figs to start with. Okay, and no other number was lower than 4 sig figs. All right, so let's go ahead and take a look at the next step, which is the next set of problems, which is going from moles to formula units, which involves Avogadro's number. All right, let's go with 6 point. How do I get rid of the red? Don't want the red. Let's get rid of the red. 6.27 times 10 to the 24th, okay, atoms of chlorine, and I want to get that to moles of chlorine. So remember, whenever atoms are involved, I need to use Avogadro's number, which is 6.022 times 10 to the 23rd. That is Avogadro's number. Very important when it comes to determining the number of formula units or atoms or whatever, okay? Or molecules, depending on what type of substance it is. So let's go ahead and get going. 6.27 times 10 to the 24 atoms of chlorine over 1. And I want to get to moles. Well, it means I need atoms of chlorine on bottom, and I need moles of chlorine on top. Well, for every 1 mole of chlorine, there is 6.022 e to the 23 atoms of chlorine. The reason why I know that is because 1 mole of anything is 6.022 times 10 to the 23rd. Could be chlorine, could be water molecules, could be donuts, which is a lot of donuts, but still, it doesn't change the definition of what a mole is. So our atoms of chlorine cancel out. I'm left with the moles of chlorine. So I do the math. 6.27 times 10 to the 24 divided by 6.022 times 10 to the 23rd. My final answer ends up being 10.4. I have 3 sig figs, so 10.4 would be my answer. 10.4 moles of chlorine. All right? And of course, if I'm doing the opposite, let's say I have 2.32 moles of iodine, okay? And I want to know how many atoms of iodine. So 2.32 moles of iodine over 1. And I know that for every 1 mole of iodine is 6.022 times 10 to the 23rd atoms of iodine. Okay? Again, moles cancel out. I'm left with atoms. I do my math, which is 2.32, okay, times 6.022 times 10 to the 23rd. My final answer ends up being, with 3 sig figs, 1.40. Okay, this number was on the calculator 1.397, blah, 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 but I need 3 sig figs. 1, 2, 3. I need to look at my next digit, which is the 7. 7 is larger than is 5 or greater, so it's going to cause that 9 to round up, which of course will cause the 3 to round up to a 4. So I end up with 1.40 times 10 to the 24 atoms. Okay, now if some people are wondering, well, when is it atoms, when is it molecules? It depends on the substance you're looking at. In both of these cases, I used chlorine, I used atoms. I used chlorine, I used iodine. Okay, if I use any sort of covalent compound, okay, if I used a covalent compound, or even not a compound, just a covalent molecule in this case, okay, I would use molecule. An example of that would be CO2, O2, or carbon monoxide, CO, O2, Cl2, H2O. Those are all covalent compounds, or in this case, this one right here is just a molecule. It's an element, okay? But they're all molecules. If I have something that's an ionic compound, okay, that ionic compound, I call those, since it's not a molecule, because substances that are held together by ionic bonds don't really have a physical bond, they just have an attraction, right, of the ions. So I just call that a formula unit. Okay? All right, so that's a formula unit. So example, that would be like sodium chloride or potassium hydroxide. Anything that's involving a metal, you're going to involve the formula unit if it's a compound. Okay? So take a look at another one, or a new set, where we'll go from mass to formula units, and then from formula units to mass. All right, how about I have 26.940 grams of water, and I want to know how many molecules of water. Okay? So, I'm going to, now here's the thing. I have grams here, and I have molecules here, which means I need to use both Avogadro's number and the molar mass. Okay? Actually, I'm going to go ahead and just make this, since we haven't really talked about yet in this video. Let's make it simple, and we'll go ahead and say grams of boron, and I want to know the number of atoms of boron. Okay? So, I'm going to go to 6.940 grams of boron over 1. Now, I don't have, if you're smart, you can really think about it and figure this out, but for simplicity's sake, let's go ahead and go one step at a time. I don't know how to go straight from grams to atoms, but I do know how to get to moles, and then from moles I can get to atoms. So, grams, the molar mass of boron, is, let's see there, 10.81 grams of boron for every 1 mole of boron. And then I also can go from 1 mole of boron to 6.022 times 10 to the 23rd atoms of boron. So here I used the mole, okay? I used that guy right there as a bridge between grams and atoms. Okay? Now, if you're good with your algebra, then you can make this a 2-step process. If you want to know about that, you're welcome to ask, but if you're having any slight problem grasping this, do it the way I'm doing it right now. Okay? So, grams of boron cancel out. My moles of boron cancel out. I'm left with atoms of boron. Okay? I do my calculation, which is 26 point, turn on the calculator, that helps, 26.940 times 6.022 times 10 to the 23rd. My answer ends up being 4 sig figs, 1.622 e to the 25th. And I'm going to divide that by 10.81. If I take 1.622 times 10 to the 25th, okay, divide that by 10.81. My answer with 4 sig figs is going to be 1.500 e to the 24th atoms of boron. All right? If I wanted to go backwards, let's say I wanted to go with atoms, or say I had 4.27 times 10 to the 21st atoms of silver, and I want to know how many grams of silver that is. Okay? So I start with what I'm given, 4.27 e to the 21 atoms silver over 1. Okay? I need to get to moles, because moles, just like here, is going to be my bridge. Okay, so I'm going to go 6.022 e to the 23rd atoms of silver for every 1 mole of silver. And then, I'm going to erase this answer right here. 1 mole of silver, so what, 107? Yeah, 107.87, or 107.89 grams of silver. And this will tell me, okay, if I cancel my units out, moles of silver cancel out, atoms of silver cancel out, I'm left with grams of silver. Okay, I do the calculation. I'm going to end up with 4.27 times 10 to the 21st times 107.89. And of course, I'm getting that 107.89 from the periodic table. And I need to have 3 sig figs in this answer, 4.61 times 10 to the 23. Okay? And I'm going to divide that by Avogadro's number, 6.022 times 10 to the 23rd. So 4.61 times 10 to the 23rd. Obviously, I'm going to have a number less than 1 right here. Okay, divided by 6.022 times 10 to the 23rd. I end up with 0. With 3 sig figs, 0.766 grams or excuse me, my bad, not grams, yeah, grams of silver. All right? So, last little set of problems I want to do is involving finding the molar masses of a covalent compound and an ionic compound. All right? So, let's pick a covalent compound and then an ionic compound. So, the covalent compound, let's go ahead and pick dinitrogen pentafluoride. Okay? So dinitrogen pentafluoride. Okay, covalence, right? That means non-metal and non-metal. Nitrogen and fluorine are non-metals. So I'm not going to look at charges. I'm just going to look at the prefixes. Okay, review my notes and then find out what the formula is. In this case, dinitrogen means 2 nitrogens, and pentafluoride, penta meaning 5, F5. And then what I'll do is, to get the molar mass of this, I'm going to take the molar mass of nitrogen, which is 14.01, and then the fluorine, which is 19.00, and then I will multiply it by the number of subscripts in the formula. So in this case, by 2 and by 5, respectively. Okay? So I'll go 14.01 times 2. That equals 28.02. And then 19.0 times 5. That equals 95.00. In both cases here, I have 2 numbers to the right of the decimal, so my answer needs to have 2 numbers to the right of the decimal, okay, when you follow the addition, subtraction, sig fig rules, okay? And then my answer is 123.02 grams per mole. This is the unit, okay? Grams per mole is the unit for molar mass. Don't just put grams, that's wrong, okay? So when I'm trying to find molar mass, this is the unit for molar mass. All right? Now, let's go ahead and take a look at an ionic compound where we will have to start looking at charges. Okay? So let's go ahead and pick, let's pick a metal. How about copper? Okay? I have copper, 2, and a non-metal. Bromide. Copper 2 bromide. So there's my name, okay? Now I need to be able to derive the formula from this, okay? I need to be able to get this, okay? If I can't get that, I can't do everything else that's important to get the molar mass, okay? So copper 2, I need to get, so this is a metal and a non-metal. So because of that, I know it's ionic, which means I have positive and negative charges. So copper 2, hey, nice enough, it is 2 plus, because remember, that's what that Roman numeral means. It gives you the charge. Now, bromine, or bromide, you have to look on the periodic table. If you look on the periodic table, bromine is number 30, bromine's number 35, okay? And bromine has 7 valence electrons, which means if it has 7 valence electrons and it wants 8, it's either going to gain 1 electron or it's going to lose 7. Well, logistically, it's just easier to gain 1. So when it gains that electron, it becomes a negative 1 charge since it only gained 1 electron. All right? Well, if I want to make a neutral compound out of this, I'm going to need an additional bromine or bromide to equal everything out. So my formula is copper 2 bromide. So I will use this formula and follow the same procedure that I did right here to get the molar mass of copper 2 bromide. Okay? Hope that helps. If you guys have any questions, ask me in class or send me an email.